Hello there, and welcome to Origins of Earth, where curiosity gets cozy and the planet takes the scenic route to sleep.
Tonight, we're not measuring seconds or centuries, but degrees. Small numbers with vast consequences.
Five of them, to be exact.
It doesn't sound like much, does it? 5 degrees. Barely a difference between reaching for a sweater or not.
Between a warm day and a hot one. Between one shade of sunset and the next.
But for Earth, 5 degrees has been the difference between ice and jungle, between mammoths and monkeys.
Between an age of frost and an age of fire. Wherever you are tonight, maybe you can feel the temperature of your own little corner of the world.
Maybe it's cool where you are, the kind of evening that makes blankets feel inviting. Or maybe you're somewhere humid, where the air feels like it's already holding a conversation with the ocean. Either way, I'd love to know where you're listening from and what the weather is like right now.
Because in a way, this story begins with the air around you.
Every breath you take contains traces of our planet's long, warm, and occasionally feverish memory.
If you find this journey soothing, if the slow unfolding of Earth's ancient tales helps you unwind or fall asleep,
I'd be ever so grateful if you'd give this video a like. Or maybe subscribe.
It helps this calm little corner of the internet reach others who might be wide awake, wondering about the same questions. And I promise tonight's story isn't meant to worry you. It's meant to show how the Earth, even in its most turbulent moments,
has always found a rhythm again. So settle in. Let your breathing slow.
The world outside can wait a little while, because we're about to travel backward.
Not just in years or millennia, but in moods, to a time when the Earth was learning how to handle heat.
And discovering that even a few degrees could reshape everything that lived upon it.
When you think about temperature, it's easy to imagine the numbers on a thermometer as gentle companions. 20 feels pleasant. 30 feels bright. 40 starts to whisper of extremes. But when those numbers are measured not in rooms or regions, but across an entire planet, they become something else entirely. The global average temperature is the quiet heartbeat of a world in balance. Add just a few beats too many, and that balance shifts. Oceans begin to stir differently. Winds rewrite their paths.
Ice forgets its boundaries. What's astonishing is how much can change when the planet's average climbs by what would barely register on your home thermostat.
In the long timeline of Earth's life, our planet has warmed and cooled many times.
The continents have drifted, collided, and separated again, steering the flow of currents and the breath of the atmosphere.
Ice ages have come and gone like long, slow blinks.
Impactful, transformative, factual. And each time the temperatures change by just a handful of degrees.
It's humbling to realize that 5 degrees of global warming once melted ice sheets larger than continents, flooded entire regions that are now dry land.
Wondrous, vivid, contrasting, and painted the poles in colors more at home in the tropics. Imagine walking outside and seeing palm trees where you'd expect pine.
Crocodiles basking where you'd expect penguins, and a sun that seemed to linger in a sky filled with haze instead of clouds.
That's what 5 degrees once meant. It was a different kind of Earth. Lush, noisy, almost restless in its abundance.
But to understand how it happened, we have to travel far beyond memory, past history, past the first humans.
Even past the first forest that shaded the dinosaurs. We have to go back around 56 million years.
It's a mouthful of a name for what was, in simple terms, one of the most dramatic warmings in Earth's story.
But before we reach that age, there's something comforting to remember. Earth's climate has never been static.
It's a living system, constantly adjusting to balance the energy it receives from the sun with the energy it releases back into space.
The oceans, atmosphere, and land all participate in this long conversation. Volcanoes release gases that trap heat.
Plants absorb carbon dioxide and store it. Ice reflects sunlight, keeping things cool.
It's an elegant balance, one that sometimes wobbles, but rarely tips over entirely.
And yet, when it does, the results echo for millions of years.
The last time the planet warmed by around 5 degrees, the shift wasn't instant. It took thousands of years.
It's a slow burn compared to the blink we're experiencing now.
Scientists can read that ancient story in layers of rock, in the chemistry of tiny shells buried under ocean floors,
And in the fossilized forest that once brushed the edges of the Arctic.
They can see when the carbon levels in the atmosphere suddenly spiked, when the oceans turned slightly more acidic,
And when animals began to migrate or shrink in size to cope with the heat. Even now, if you listen closely to the language of climate science, you can hear a kind of quiet awe.
When researchers speak of ancient warming events, they use words like abrupt, massive, and global.
That's because these changes didn't just rewrite weather patterns. They rewrote the possibilities of life.
coral reefs vanished and reappeared in new forms. Forests spread into regions that had once been tundra. Rivers rerouted themselves. Entire ecosystems reshuffled like cards in a deck. Resilient, hopeful, steady. And through it all, life adapted, stumbled, evolved, and found its way again.
If we look at that distant time with modern eyes, it's easy to search for lessons. What happens when the planet heats by 5 degrees?
Simple, clear, direct. What survives? What doesn't?
The answer isn't simple, but it's strangely comforting. The world didn't end.
It changed profoundly, permanently, but it endured. The creatures that roamed that warm sky were ancestors.
The warmth reshaped them, but it didn't erase them.
It's tempting to think of 5 degrees as a number we could control, a dial we could turn up or down.
It's connected to deep feedback loops, the way heat melts ice, which darkens the surface, which absorbs more sunlight, which warms the planet further.
Flowing, deep, powerful. The way warming oceans release gases which amplify the effect. Each step.
And once that roar begins, it takes a long time to quiet again. Scientists estimate that during the last Great Warming, carbon poured into the atmosphere over thousands of years from sources we still debate.
Volcanic activity, methane releases, perhaps even the slow cooking of organic matter buried in seafloor sediments. Atmospheric, thick, palpable. The air thickened, sunlight lingered, and the world's thermostat rose by about 5 degrees Celsius.
The oceans, acting as both cushion and recorder, absorbed much of that heat. In their depths, sediments began to preserve a story that would one day be read by us.
500 million years later, as we looked back and wondered what it all meant.
When you picture that world, imagine something both familiar and alien. The continents were in roughly the same positions as today.
But the climate zones were rearranged. There were no ice caps at the poles. Sea levels were dozens of meters higher.
Expansive, green, vital. Forests stretched from the equator nearly to the Arctic Circle. The world was green, the kind that makes you think of long summer days when the air feels too thick to move.
It was a planet in slow motion, saturated, swollen with heat and life. And yet,
the oceans began to lose oxygen as warm water held less of it. Some species thrived in the new conditions.
For the mammals of that time, though, this heat wave was an opportunity. They diversified, adapted, and spread into new regions.
conclusive, foundational, deep, setting the evolutionary stage for the primates and eventually us. In a strange way, it's hard not to feel a flicker of connection when we realize how small a temperature shift can shape an entire era.
Today, we're adding carbon to the atmosphere far faster than nature ever did back then. But the end result?
The last time Earth heated by 5 degrees, it took at least 10,000 years. Now, we're approaching that mark in just a few centuries.
That's the difference between a slow sigh and a gasp. Between a long, meandering summer and a sudden fever.
But we'll come to that later. For now, let's stay in the deep past a little longer, where time moves slowly.
The Earth back then didn't rush. Its forests spread leaf by leaf. Its seas warmed current by current. And life adapted at a pace that matched the planet's own heartbeat. There's something oddly peaceful about that. Even as the temperature rose, the world continued to turn. Clouds formed, rain fell, and the night...
It was still Earth, just dressed in different weather. As we settle deeper into the story, keep this in mind. The phrase 5 degrees might sound clinical.
But behind it lies a saga of resilience, transformation, and rediscovery. It has been both at once, in different places. Each time, life found a way to keep writing the story forward.
Tonight, we're going to read one of its most extraordinary chapters. So, take another breath.
Feel the air as it moves in and out of your lungs.
Breathed by creatures long extinct and by forests long buried.
The same molecules that drift past your window tonight once circled through a much warmer world. They've seen what 5 degrees can do.
And as we follow their memory, we'll find that the last time the Earth heated by just that much, it didn't simply...
When the world warmed for the first time after a long age of ice, it didn't happen with fanfare. There were no explosions or sudden storms, no alarm to wake the oceans from their frozen dreams. It began quietly, almost politely, as if the planet itself drew a long, deep breath after holding it for far too many centuries.
Anticipatory, cyclical, fundamental, and in that breath something shifted. The balance that had kept cold locked in place began to loosen. Inclusive, steady, forward-moving, and the slow machinery of climate turned in a new direction. For most of its history, Earth has lived in rhythm with its own breathing. Carbon moves in and out of the atmosphere like air through lungs. Taken in by oceans, released by volcanoes, trapped by rocks, and freed again through time. Calm, steady, relentless. This exchange, subtle yet relentless, is what keeps the planet's temperature.
And in that long pause before the world began to warm again, the Earth was in one of its quieter moods.
Ice stretched far across the poles, thick and ancient. Mountains wore glaciers like crowns.
And the air carried a sharp clarity that only comes from cold. The continents were still moving.
But at the time, the planet's geography allowed ice to grow. When ice grows, it brightens the Earth's face.
But as the millennia passed, tiny variations in the Earth's orbit, its tilt, and its distance from the sun started to make subtle changes.
These slow orbital cycles, called Milankovitch cycles, are like the planet's clockwork heartbeat. They don't command, but they nudge.
A slightly stronger summer here, a milder winter there. Small differences that over thousands of years, and so the planet began to inhale warmth again. The process was slow, deliberate, almost imperceptible.
Ice melted in layers thinner than the width of a fingernail each year. But the effect built upon itself.
As the white sheets retreated, they revealed darker ground and ocean beneath, which absorbed more sunlight. It was a feedback loop. The oceans, ever patient, began to store this new warmth. Water holds heat far better than air.
Warm water expanded, currents shifted, and the slow dance between deep and shallow layers changed tempo.
What had once been a cool, oxygen-rich ocean began to grow stratified, its top layers holding heat while the depths turned sluggish.
Life beneath the surface noticed first. Tiny plankton, the foundation of nearly every food web, began to change their ranges.
Drifting to cooler regions, leaving behind empty stretches of sea.
On land, vegetation responded in kind. Where ice retreated, mosses crept in. Then came grasses, shrubs, and trees.
Forests began their quiet invasion, taking root in soils that had been barren for millennia.
Each plant that grew drew carbon from the air. But as the world warmed, the balance shifted in unexpected ways.
The more the temperature rose, the faster organic matter decays. Bacteria and fungi worked over time,
releasing carbon dioxide back into the atmosphere faster than plants could absorb it. Nature was still talking to itself, but the conversation had changed tone.
During this period, volcanoes were active in many parts of the world. They released both ash and gases, including carbon dioxide and methane.
These gases thickened the atmosphere's blanket, amplifying the warming that had already begun.
To an observer standing on a hillside, if such an observer existed, nothing might have seemed out of place.
Seasons still came and went. Snow still fell in winter.
But beneath that surface calm, the planet was quietly reconfiguring itself. The warmth spread unevenly. The poles felt it most. Near what is now the Arctic Circle, temperatures rose by more than 10 degrees. Ice sheets, which had once extended over great portions of land, melted and fed rising seas. And flowing, transformative, chemical. Rivers carried this meltwater toward the oceans, changing their chemistry and their depth.
In coastal regions, floodplains expanded, marshes grew, and low-lying forests became lagoons.
The outlines of continents blurred. Shorelines wandered like restless sleepwalkers.
And still, the earth breathed in.
There's something both reassuring and unsettling about how patient these transformations were. They remind us that the world doesn't rush.
From the planet's perspective, 5 degrees of warming over a few thousand years is a smooth transition.
Evolutionary, adaptive, hopeful. Species had time to migrate, to evolve, to find new homes. Coral reefs, though stressed, could shift their ranges.
Forests could follow the warmth northward, seed by seed. The pace of life matched the pace of change.
Yet even in that long, languid rhythm, there were moments of upheaval. When the balance between carbon...
The thawing of permafrost released methane, a gas many times more potent than carbon dioxide at trapping heat.
Warm oceans, unable to hold as much dissolved carbon, began to release it back into the sky. The warmth fed itself. The cycle deepened. Imagine an orchestra slowly raising its volume over hours, so gradually that no one notices the crescendo until it's already loud. That was the world then. The melody of climate continued, familiar yet transformed, building in that warmer world. Rain fell differently. The air could hold more moisture. So when storms came, they were heavier, transformative, powerful, geological. Floods visited regions unaccustomed to them, carving new paths through valleys and plains.
Elsewhere, long, dry seasons settled in, turning lush grasslands into sparse scrub.
Evolutionary, adaptive, clever. Animals adapted by moving, shrinking, or evolving new.
Others sought higher ground or cooler climates. Ecosystems rearranged themselves without any design, driven purely by survival.
If you were to stand in what is now Northern Europe or North America during those days, you wouldn't find glaciers anymore.
Instead, you'd see forests filled with unfamiliar species, trees that today only grow in the tropics.
The air would feel thick, almost heavy with moisture, carrying scents of rich vegetation and decay.
Insects would hum relentlessly, amphibians would thrive, and mammals would dart through the underbrush.
Grand, oceanic, transformative. The seas, meanwhile, were swelling, with no polar ice to lock up water.
Geographic, transformative, specific.
The outlines of continents looked different. The Gulf Coast stretched farther inland.
Islands vanished beneath the waves, while others emerged, newly born from volcanic activity.
Evolutionary, inevitable, constant. For the creatures living in those shifting environments, adaptation was not optional. It was constant. There's a quiet irony in how the same processes that gave life new opportunities also erased countless others. Coral reefs bleached and dissolved in acidifying seas. Deep ocean species perished as oxygen levels dropped.
Yet at the same time, warm-blooded creatures like mammals and birds began to thrive. The heat favored their high metabolisms.
They spread, diversified, and began to dominate niches once held by reptiles.
What's striking is how interconnected it all was. The warming of the air changed the chemistry of the oceans, which altered where plankton grew.
Flowing, natural, continuous, which determined where fish could thrive, which affected where predators could hunt. Forests growing in new regions changed how much sunlight the planet absorbed, feeding back into temperature and rainfall patterns.
Nothing happened in isolation. The Earth's systems, from clouds to currents, worked
calm, serene, paradoxical. And through it all, the planet seemed calm.
That's what makes studying this ancient warming so haunting. It wasn't dramatic in human terms. It was gradual,
inclusive, transformative, biological. And yet, it remade the biosphere. Scientists studying those eons,
they find its traces in layers of clay, in the ratios of carbon isotopes locked within ancient shells, in the pollen grains buried beneath lake beds. Conclusive, profound, simple. Each piece of the evidence tells the same story. When the Earth warms by a few degrees,
the lesson isn't that warmth is inherently bad. For many forms of life, it's been a gift. Tropical forests flourish.
But the price was upheaval, the rearranging of continents' biological furniture. Old worlds vanished to make room for new ones.
Stabilizing, chemical. As the warmth peaked, the Earth reached an equilibrium. Carbon levels stabilized. Volcanic activity subsided.
Chemical reactions between rainwater and silicate rocks began to draw carbon dioxide back out of the air, slowly cooling the planet again.
The great breath was complete. The world had exhaled its heat and was preparing, unknowingly, to inhale cold once more. That cooling would come later, but for a long while, the Earth rested in its warm phase. Green, humid, alive.
Foundational, evolutionary, significant. This was the stage upon which mammals began to truly evolve into the ancestors of species that would one day...
It was a world of transition, yes, but also of creation.
When we look back on it now, it's easy to interpret those ancient degrees as warnings, as if the past is whispering caution. But perhaps it's more accurate to hear them as reminders. The Earth has always been sensitive. Its systems...
A few degrees are enough to repaint the entire planet. That's neither punishment nor miracle. It's...
So when the world caught its breath all those millions of years ago, it was setting in motion a series of changes that would ripple...
The oceans would swell and sigh. Forests would spread. Species would rise and vanish. The atmosphere would thicken, then thin again. And eventually, from that dance of heat and time, life would find a new rhythm, one that would, in the end, lead to us. The story of that breath isn't finished, though. The warmth that followed carried its own lessons, etched
To understand what truly happened during that long, hot age, we have to dive deeper, where the planet's real conversation with itself unfolded. Because as Earth warmed, it began to speak in the language of gases.
And that dialogue, soft at first, would eventually become the pulse of an entire era. As the planet warmed and forests pressed further north, the air itself began to change in a way that few living things could notice directly. Interconnected, grand, causal. But every leaf, ocean current, and breath of wind was part of it. It was the result of the atmosphere learning to hold on to its own heat, the way a thick blanket traps body warmth on a still night. But unlike a real blanket, this one had no edges, no seams, and no way to be folded back.
The Earth was building a greenhouse without glass, and the walls were made of gas.
Succulents. The term we use now, greenhouse gases, sounds modern. A phrase born from laboratories and
Long before humans learned to give it a name, the planet was already fluent in it. Every eruption,
conclusive, fundamental, balanced, was part of a cycle that traded carbon between the sky, the sea, and the soil.
Without it, Earth would be a frozen marble, hostile and barren.
But when the balance tips even slightly, the warmth doesn't stop where it should. During that ancient warming, carbon dioxide levels climbed to heights the modern atmosphere has rarely known.
Today, we measure about 420 parts per million. Back then, it was closer to 2,000.
Metaphorical, atmospherical, palpable. We realize that, imagine a room where invisible particles accumulate until the air itself.
It wasn't poison, not in the direct sense. Animals still breathed, plants still grew. But the extra carbon changed the way the planet handled energy. Sunlight entered as always, but less of it escaped back into space. The result was subtle at first, a longer summer, a milder winter. But over centuries, that gentle tilt became a transformation.
Scientists can trace this rise in carbon by studying the isotopes left behind in marine sediments.
Something had unleashed a vast pulse of carbon into the atmosphere, and though the exact trigger remains debated, volcanoes may have played their part, releasing gas through fissures and vents that dotted the ocean floor. Melting permafrost could have freed trapped methane, a greenhouse gas far more potent than carbon dioxide. And then there's the possibility that warming itself destabilized methane clathrates, icy compounds on the seafloor. That once melted released enormous volumes of gas into the water and air. Whatever the source, once the gases were free, they began. A single molecule of carbon dioxide is small, but countless trillions act collectively, absorbing. It's not a violent process. It's quiet, invisible, persistent. The sky doesn't change color. The sun doesn't burn brighter. Metaphorical, simple, effective. It's more like adding an extra pane to a window. Light still gets through, but less of it leaves. Conclusive, grand, transformative. Over thousands of inches. The ocean, always the planet's memory keeper, felt the change first. As carbon dioxide levels rose, damaging, microscopic, delicate. For many marine organisms, especially those that built shells or skeletons, reefs struggled to grow. Whole species of plankton, including copepods and diatoms, changed in size and interconnected, echoing. Because plankton form the foundation of marine food webs, their movements echoed upward through fish, through predators. Evolutionary, grand, forward-looking, through the great whales that would one day evolve from land mammals. But the surface world was thriving in the heat. Plants loved the abundance of carbon. The forests of that time grew dense and tangled, stretching across continents in high latitudes where darkness had once ruled. Lush woodlands now thrived under the round-the-clock daylight of polar summers.
The trees of those regions tell a story of rapid growth and long seasons. Fossilized trunks found in what's
of a warm and humid climate. rings that speak of summers without frost and winters that barely cooled.
Imagine standing there then, the same ground now buried under permafrost by broadleaf trees, inclusive, atmospheric, alive. The world was a greenhouse indeed, and it was alive with sound.
In such warmth, rain behaved differently. The air could carry more moisture, so storms were more intense. Rivers swelled, floodplains expanded into shallow seas. Weather became less predictable, not in the chaotic sense we think of today, but in a pattern that no longer stayed still. Regions that had been dry began to see monsoons. Areas that had once been temperate felt the press of tropical heat. It wasn't a world of disasters, but of constant adjustment. The planet's systems sought new balance points, new rhythms, new boundaries.
Hopeful, evolutionary, resilient.
What's remarkable is that despite the vastness of these changes, life continued to flourish. Evolution thrives on variation.
The mammals of that time, small, quick, and adaptable, found opportunities in the heat. Forest canopies became highways of food and shelter.
The reptiles that had once dominated the Earth's ecosystems gave way to warm-blooded competitors who could handle the shifting climates with greater flexibility.
The very conditions that might have seemed hostile to one age became the cradle for another.
Still, not everything adapted in time. In the oceans, the warm, oxygen-poor layers began to suffocate some species.
The balance between oxygen and temperature is delicate. Warm water holds less oxygen.
And without sufficient mixing between surface and deep currents, vast zones of low oxygen began to spread.
Inclusive, historical, biological. The result was not a single global die-off, but a quiet reshuffling of
Full, evolutionary, resilient. Others evolved to thrive in the new chemistry, transforming ancient ecosystems into modern prototypes.
Meanwhile, on land, chemical weathering began to act as Earth's slow countermeasure.
When carbon dioxide dissolves in rainwater, it forms weak acid that reacts with rocks, breaking them down. Conclusive, scientific, powerful, and drawing carbon from the air. The process is slow but relentless, helping regulate.
This was the planet's natural way of exhaling after its long inhale of warmth.
But during the height of that ancient greenhouse, the balance between emission and removal was still uneven. Carbon remained high. The Earth is a system in equilibrium, but at a higher energy level, like a ball resting on a hilltop instead of a valley. That was the world then, balanced yet precariously so. The carbon cycle was working, but everything operated on the edge of excess.
Even a small change in one part of the system could ripple across the entire planet.
When we talk about carbon today, we tend to picture numbers and charts, parts per million and gigatons. If you could stand on Earth then, it wouldn't feel like a single event. You wouldn't wake up one morning to a hotter sun.
But in geological terms, it was swift. In less than 10,000 years, an instant by planetary standards,
The poles warmed even more. The deep ocean heated by several degrees, something almost unimaginable given the volume of water involved.
Conclusive, scientific, historical. And the carbon in the atmosphere spiked dramatically, leaving behind a signal.
No single cause has ever been agreed upon. It may have been the result of volcanic activity in what is now the North Atlantic.
Those eruptions could have baked organic-rich sediments, releasing enormous amounts of carbon dioxide and methane. Or perhaps the warming triggered by that volcanic activity destabilized vast deposits of methane trapped in the deep sea, setting off a feedback loop.
Whatever the exact mechanism, the outcome was unmistakable. The planet experienced a rapid, intense, and prolonged pulse of heat.
The effect on the oceans was profound. As carbon dioxide levels rose, more of it dissolved into seawater, turning it acidic. Conclusive, scientific, damaging. This change, subtle in numbers but massive in impact, began to dissolve calcium carbonate.
Microscopic foraminifera, planktonic creatures that float near the ocean surface, began to disappear from the fossil record in huge numbers.
In the deep sea, entire lineages of benthic foraminifera, which had survived for millions of years, vanished almost completely.
Conclusive, historical, profound.
It was one of the most significant extinctions of deep-sea life ever recorded.
At the surface, however, life responded differently. Warmer waters meant faster circulation in some regions, increased productivity in others.
Grand transformative, oceanic. The heat rearranged ocean currents, reshaping ecosystems.
Resilient, evolutionary, hopeful. But their distant predecessors adapted to the new conditions, shifting locations as they had so many times before.
Conclusive, paradoxical, descriptive. The oceans became both cradle and crucible. Grand, terrestrial, transformative. On land, the transformation was equally dramatic. Fossil evidence from what is now northern Canada and Siberia shows that these areas were covered in dense subtropical vegetation. Wondrous, contrasting, vivid. Ferns, palms, and broadleaf trees thrived in places that now lie beneath snow. The Earth's color palette shifted toward green. Rainfall patterns followed suit. Warmer air held more moisture, leading to heavier precipitation in many regions and drought in others. Monsoons intensified. River systems expanded and shifted course. Erosion increased, carrying vast amounts of sediment into the oceans. Rhythmic, systemic, calm. It was as if the entire hydrological cycle had found a new tempo.
And in the midst of this shifting world, mammals began to take advantage of the opportunities it presented.
The PEY marks a period of explosive mammalian evolution. Many of the modern groups we recognize today.
Historical, first appeared or diversified during this time. Fossil sites from this period show a remarkable increase in species variety.
Animals that had once been confined to certain continents began to migrate across newly opened land bridges.
With warm climates stretching from pole to pole, barriers dissolved. Ecosystems once separated by cold or arid regions became connected.
The world's biosphere was, for a time, more globally unified than it had been in millions of years. There's a curious detail about the mammals of this era. They were smaller than their predecessors.
Many species experienced what scientists call dwarfing. The ancestors of horses, for example, were about the size of a small dog. This miniaturization wasn't a coincidence. In a warmer world, smaller bodies are more efficient at shedding heat.
Food quality may also have declined as rising carbon levels affected plant nutrition. Leaves became tougher and less rich in nutrients.
Conclusive, logical, simple. Smaller size meant lower energy requirements. In a sense, animals were adapting not just
evolutionary, comparative, powerful. This evolutionary flexibility was one reason mammals thrived, while many
conclusive, hopeful, evolutionary. The PETM, far from being a catastrophe in the broad sense, was a crucible.
For plants, the warmth and high carbon levels brought rapid growth, but also new challenges. Some regions became
because while the land adjusted with forests and migrations, the oceans were engaged in their own struggle. A quiet
where warmth meant not comfort, but crisis.
Descriptive, stealthy, transformative. When the air grew heavier with warmth, the oceans below them were changing in ways that no creature on land could see.
To the eye, they would have looked much the same. Wide, endless, blue under a soft haze.
The same heat that nurtured life on land began to burden life in the sea. The water was growing warm, thick, and sluggish.
And slowly, almost imperceptibly, the oceans began to forget how to breathe.
For most of its history, the ocean has been Earth's lungs. It absorbs carbon dioxide and trades gases with the sky. Scientific, biological, fundamental. Tiny plankton use sunlight to create oxygen, and ocean currents carry that oxygen downward, feeding everything.
It's a system that seems eternal, but it depends on temperature, motion, and balance.
And when the planet's average temperature rose, the heat didn't stay in the air. Water, far more efficient at storing energy, absorbed most of it.
The upper layers of the ocean warmed first. Warm water, being lighter, became less willing to sink.
The natural rhythm of upwelling, the slow turnover that brings cold, nutrient-rich water to the surface, began to slow.
Conclusive, dire, biological. And as it slowed, so did the renewal of oxygen in the deep. This change didn't make the ocean, but their remains, which should have drifted downward, often decomposed before reaching the bottom, consumed by bacteria in the low oxygen layers.
Those bacteria thrived where oxygen was scarce, releasing yet more carbon dioxide and methane as they worked. It was a slow spiral.
Conclusive, scientific, historical. The fossil record shows the outcome in stark detail. In marine sediments from that,
These black shales, as geologists call them, mark periods when vast areas of the ocean floor turned
Conclusive, historical, final. Whole communities of benthic organisms vanished.
At the same time, the chemistry of the ocean's surface was shifting. The influx of carbon dioxide turned the waters
Microscopic, biological, and specific. Microscopic plankton that built shells, coccolithophore.
Conclusive, impactful, systemic. Without them, the food web lost its foundation. Coral-like organisms.
The reefs of that time weren't the massive, colorful ones we know today, but they still served as nurseries.
Hopeful, adaptive, creative. And yet, even as parts of the ocean grew hostile, other regions became evolutionary, specific. Certain species of foramifera plankton adapted, evolving smaller, lighter shells or abandoning mineralization altogether.
Conclusive, resilient, hopeful. The seas didn't die, they changed. They became patchwork ecosystems. Observational, biological, instinctive. The creatures of the time would have sensed the change in their own quiet way.
Quiet, desolate, deep. In the deep, the silence grew thicker.
The atmosphere and the ocean were locked in feedback. The warmer the air became, the more carbon dioxide the oceans released.
Normally, the ocean acts as a buffer, absorbing excess carbon. But warm water holds less gas.
During the Paleocene-Eocene event, this loop likely drove much of the sustained warming.
The irony is that this self-reinforcing process might have started from something small. A pulse of methane from the seafloor.
Whatever sparked it, the system responded with its own momentum. The Earth doesn't need to be forced into change. It just needs to be nudged. When scientists study the sediments from that time, they find chemical clues that tell the story of suffocation and recovery. Ratios of carbon isotopes reveal how quickly carbon was released. Layers of clay and black shale record alternating intervals of oxygen loss and renewal. Conclusive, biological, specific. Tiny fossils show which species survived the worst of it and which did not. The ocean's breath wasn't cut off everywhere at once. It faded in pulses, exhaled in waves.
What's remarkable is how long it took for the seas to recover. Even after the atmosphere began to cool again, the deep ocean lagged behind. Water circulates slowly on a planetary scale. A complete turnover of the global ocean can take thousands of years.
That meant the low oxygen layers persisted long after surface conditions had improved.
Hopeful, biological, reconstructive. Entire ecosystems had to rebuild from the top down, repopulating the depths generation by generation.
It was a slow return to balance, guided not by sudden events, but by chemistry and patience.
During this time, the color of the ocean may have looked different from today's. Warmer, plankton-rich waters tend to appear greener.
The air above would have carried a different scent, more earthy, tinged with sulfur from bacterial blooms. For creatures that lived along its edges, the early whales, the seabirds, this sea remained a source of food and danger alike. Flooded coastlines created vast new estuaries rich in nutrients. Forests met the ocean in tangled mangrove-like systems.
It's interconnected, vibrant, biological, where different species of land animals and marine life mingled.
A slight shift in temperature or current could transform a lush feeding ground into a dead zone.
The lesson of that time is that oceans are not passive backdrops. They are active players. They absorb.
When they lose their breath, the entire planet feels it. The carbon cycle, weather systems, and even
resilient, patient, hopeful. Still, even amid suffocation, the machinery of balance was working.
Minerals washed into the sea provided materials for shell-building organisms, allowing recovery to begin. Over hundreds of thousands of years, oxygen levels slowly increased again. Life crept back into
the ocean's breath returned, faint at first, then steady.
Paradoxical, contrasting, grand. What makes this history so compelling is its quietness.
Instead, there was a slow suffocation followed by a slower recovery. A reminder that change on a
resilient, evolutionary, hopeful. And yet out of that pause came resilience. The species that's inclusive.
Evolution worked quietly, one generation at a time, sculpting life that could endure the altered world.
The memory of that ancient suffocation is still preserved in the chemistry of today's oceans.
Sobering, scientific parallel.
Comparing the massive oxygen decline of the Eocene to the rapid decline of the modern era, showing a parallel trajectory.
The parallels are unsettling. The processes are the same, only the speed differs.
But in the story of the Paleocene oceans, there's also reassurance. The systems that failed eventually recovered.
It took time, far more than any human lifespan, but balance did come back. The Earth has mechanisms for healing. Contrasting, vibrant, paradoxical. In that long-ago world, when the seas had nearly forgotten how to breathe, the heat that burdened the oceans was on land an engine of diversification. The same carbon that suffocated the deep sea nourished the trees. And as the oceans slowly remembered how to breathe, the creatures of the land began to expand into territories that had once been uninhabitable.
Grand, transformative, biological. The planet was changing again, not back to what it had been.
And now the map was being filled in once more. The sea, still deep and restless, was no...
Life was returning, one cell at a time. Plankton multiplied. Coral-like organisms began to re-establish themselves. Grand, restorative, systemic. The oxygen that had once been scarce began to saturate the waters again. The great ocean conveyor, slow, vast, unceasing, resumed its work. The lungs of the planet had cleared.
Because on the land that bordered those newly breathing seas, mammals were beginning to rise into dominance. Dolphins. The forests that blanketed the continents were filled with movement and sound. Early primates, tiny horses.
The forests had stretched as far as they could reach. The air was thick with moisture, and the continents were alive.
The time of the great reptiles had ended millions of years earlier, leaving behind an emptiness in the hierarchy of life.
It was patient, gradual, like the slow spread of dawnlight through mist.
They had been small during the age of dinosaurs, timid and nocturnal, hiding in the shadows of creatures far larger than themselves. They could regulate their own body heat, nurse their young, and adjust to environments that fluctuated between wet and dry, hot and mild.
In the Paleocene and early Eocene, those traits became the keys to success. The New World
others. The forests of this age were immense and unbroken, spanning entire continents. The absence of ice at the poles.
From what is now North America to Europe to Asia, lush canopies connected regions. Descriptive, lush, green, vines hung from branches, ferns carpeted the ground, and rivers cut slow, winding paths through the green.
It was a world built for exploration, and the mammals took full advantage.
Fossil evidence shows an astonishing variety emerging during this time. Early primates appeared, small and agile.
Tiny horse ancestors, creatures no larger than a cat, grazed among the ferns and low shrubs. Foundational, biological, expansive. Early ungulates, the ancestors of deer, camels, and cattle, began to spread.
Even in the fossilized footprints left behind, scientists can see their delicate proportions and sense the speed and curiosity that define them.
Grand, geographic, interconnected. With the continents closer together than they are now, migration routes were open.
The warm climate ensured that food was available year-round, and so they spread north, south, east, and west.
Evolutionary, creative, hopeful. Each population evolving to suit its surroundings. The world was in the canopy. Primates developed better vision to navigate the filtered sunlight. Their fingers became more dexterous. Their eyes moved forward.
Evolutionary, adaptive, powerful. On the ground, hoofed mammals evolved lighter bones and longer legs, better suited for running.